Hi, I'm Keenan Casey for TutsPlus. In this lesson, we're going to start looking at the second main type of machine learning, unsupervised learning. You recall that in this course, we've started by looking at supervised learning, classification and regression. Now we begin the unsupervised portion. We'll talk about clustering and association analysis. Lastly, we'll hit on the theory and practice. Let's remember the differences between supervised and unsupervised learning. Supervised learning is really just prediction. In this case, you know what you're looking for. That is, you know the right answer. You know the right mapping from inputs to outputs. And we see this in the form of classification or regression. In unsupervised learning, we're essentially doing grouping. We don't know what we're looking for. We don't know the right answers. We just have a lot of input. Two ways that we see this implemented are through clustering algorithms and association analysis. In unsupervised learning, we're essentially asking, given some input, what can you tell me about it? What similarities or patterns exist in the features of X? Or what are the 5 best groups that we can make from our data set? What's distinctive about that group? In contrast, in supervised learning, we're basically always asking the question, given this input, what's the output? So what's the point of unsupervised learning? Basically, we're trying to find similarities in the raw data. We don't have a right classification, a right regression value. We're just trying to find similarities. The first type of unsupervised learning we're going to consider is clustering. In clustering, we have a set of data, which we can imagine are just inputs. We put that input data through a learning algorithm, and it produces a set of clusters, a set of groupings, where the things in each cluster are more similar to each other. So clustering is all about partitioning the data into groups that are similar. Association analysis is another type of unsupervised learning. In this case, we have a set of inputs that we're going to imagine as sets of items. When we put that through a learning algorithm, it will produce a set of associations, items that frequently occur together, as well as rules that describe these correlations. Association analysis is about finding patterns among the features, among the components themselves. First, let's look at an example of clustering. Imagine we have this data that plots GPA along the x-axis and number of the Lord of the Rings books read along the y-axis. And I've added a little bit of randomness to this so that all the data points aren't right on top of each other. How would you divide this data into groups or clusters? How many clusters should there be? Well, let's just start with 2. If you could break this into 2 groups, what would that look like? Well, I think we might put one on the left of the low GPAs and one on the right of the higher GPAs. Well, if you had 3 clusters, could you do a better job? Maybe so. Let's look at that. If we had 3 clusters, we might separate that right cluster into high GPA, large number of Lord of the Rings books read, and high GPA, low number of Lord of the Rings books read. Well, that's better, and that may be more informative as to what the natural groups in this data are. But what if we had another cluster? How would we further subdivide this? Well, we might break that left group into 2 groups as well, into the high and low number of Lord of the Rings books read for low GPA individuals. So this is an example of how we can create clusters within a data set that organize similar instances together. Next, let's consider an example of association analysis. Assume we have this data set like so for our geeks, where we have information about their browser of choice, how much they like Legos, how much they like bacon, and the number of Lord of the Rings books they've read. If we put that through an association algorithm, what it will produce is a set of items that are associated with each other. So the algorithm might find that Chrome and Lego love equals 4 often occur together. It might also find that Chrome, Lord of the Rings equals 4, and bacon equals extremely interested often occur together as well. Or perhaps that Safari and the number of Lord of the Rings equals 0 occur frequently together. This is an example of association analysis. As we consider unsupervised learning, we're going to look at the following algorithms. For clustering, we'll look at 3 types of clustering: the k-means clustering algorithm, hierarchical clustering, and self-organizing maps. For association, we're going to look at the most common algorithm, the a priori algorithm. In this lesson, we've looked at the basics of unsupervised learning. We've seen clustering, which is essentially grouping instances together based on similarities, and association analysis, which is sort of grouping features together based on common associations among them. So this is our course. We're in the unsupervised section. We'll be considering clustering and association analysis as unsupervised learning algorithms. I'm Keenan Casey for TutsPlus. Thank you for watching.